virtual session 3 for Earth Science, woo! Which I'm excited because I converted this almost into a biology lesson, which makes me happy because, no offense to Earth Science, but it is my least favorite science. So we are going to be going through a lesson here about the water cycle and human impact on the water cycle. I recommend that you take notes during this. So if you don't have paper or a document or something that you're going to take notes in, please get that ready. And I'm going to start this presentation. So our essential question is not loading, even though, why is this taking so long to load? Okay. Our essential question today is, how do humans impact the water cycle? Which doesn't sound like the most exciting thing ever, but honestly, it kind of is exciting. Water cycle is pretty easy, but human impact is a little bit more complicated. So this is going to support your learning for lesson 1.01 in Canvas. So a lot of you guys probably haven't gotten to that lesson yet, but you will be getting there next week. So this is going to basically cover all of the stuff in that lesson, plus more. And that's going to sort of set you ahead here. You're not going to have to actually go through that lesson in Canvas. You could still look through it if you want, but I pulled all the key information out. So our objectives are going to be to describe the water cycle, identify properties of water, and also identify potential human impacts on the water cycle. So our warm-up question here is, what do you already know about the water cycle? Draw or describe the steps that water goes through on Earth, or the phases that water goes through on Earth. Right, so just take a second here. I want you guys to draw or write or describe either on the computer or on a piece of paper what you know about the water cycle. Oops, almost gave it away. All right, about 30 seconds left to draw or describe the water cycle. All right, so what did you guys draw or describe? Can I get some words in the chat here of what we know about the water cycle? What does water do? Evaporates, good. It's definitely part of it. Condenses. Precipitates. repeats. Yeah, it's a cycle, right? It's repeating over and over. Ooh, runoff, my favorite one. An important one. Plant uptake. Ooh, okay. Awesome. Evaporation, condensation, precipitation, sublimation. Ooh. Okay, you guys, fancy vocab here. Maybe some of you guys have already gone through this lesson. Or you might remember this, right? Because water cycle is probably taught like every year of science that you're in. Infiltration. Okay, we got a lot of words. So I would recommend for your notes that you print out some kind of water cycle diagram, right? I just found this one from the USGS, United States Geographical Society, I believe is what that stands for, or Geological Society. That's the word I'm looking for. Geology. And I would make sure that you know what all these words mean, right? I'm not going to go over the definitions of what they mean because I think a lot of us already know. But just in case you don't, make sure that you know what these words mean. So we'll review a few of them here. But we see this beautiful cycle, right? We see that the oceans are evaporating. Plants are evapotranspirationing. What does that mean? Yeah, Haley said that in the chat. She said evapotranspiration, I think. Yeah, what does that mean? It's really just that plants release water out of their leaves, right? So water is released / evaporates out of the leaves. It just sounds complicated, but it's really not that complicated. Water is getting released or evaporates from the plants. Yeah, and it's flowing out in gas form, exactly. Right, which is not good for plants because they need that water. So that's why they can actually end up getting wilty if too much water is evaporating out of them or they're not getting enough water. We have surface runoff, right, which is basically when water is draining back towards an ocean or lake or river. We have water in gas form in the atmosphere. It's precipitating, right? Could be ice, snow, could be rain. It's infiltrating into the ground, right? Seepage means that it's going from the ground back into a stream or river. Yeah, good point, Haley. Never water your plants in the middle of a hot day. It's true. And you see people doing it all the time. And you're like, what are you doing? Plants absorb some of that water right into their roots. And also we have this weird phase change here, sublimation and desublimation. Does anyone remember what phase that is? That's probably one of the harder ones, I think, sublimation. Because we don't always think about that phase change. Good. Thank you, Erica. Water goes from a solid to a gas, skipping the liquid. Right? So that would be like snow on top of a mountain becoming a gas. Or a gas becoming a solid, in this case, ice or snow, and skipping the liquid form. So that's kind of a weird one, but it's part of the water cycle. We got a comment here from Sydney. Plants produce their own food, but they need water, and every kind of living thing on Earth releases any water intake. Yeah, you're exactly right. Water, even in us, it's not staying in our body, right? We're releasing it in urine, in sweat. Even when you breathe out, you're breathing out some water in gas form. Oh, I'm sorry. You go by River? Thank you. It just shows Erica as your name there, but I will call you River now. So make sure you have a water cycle somewhere in your notes. Even if you print this one, Yeah, so just make sure you have that. That's all I have to say. Pretty much a review, I would say, for most of us. If it's not, make sure you know what all the words mean. All right, so there's also some important vocabulary associations here with water, right? We see two main prefixes for water, hydro and osmo. Anytime you're seeing hydro or osmo, it's something about water. We see things like hydrosphere, right? Meaning literally the parts of Earth that have water. Hydropower, water powering something. So think about water running down through a dam that can generate electricity. A hydrologic cycle, right, which is another fancy way of saying the water cycle. And then we have also osmo. We have something called osmosis, which is water exchange in cells, and osmotic pressure, which is the pressure that water can create. Right? So if you're seeing hydro or osmo, that's a fancy way of saying water. And that's going to help you pretty much, if you see words that start with those prefixes, you'll automatically start thinking, oh yeah, this is about water in some way. So the structure of water is also a super important concept here. Water is really special, right? We don't always think about that because we see it all the time, we encounter it all the time, and it just seems normal to us, right? But compared to other liquids and substances on Earth, water does some weird stuff. So I put a ton of pictures here. But really, we want to talk about water is a polar molecule. What that means is that it has charges in it, right? Water is made of an oxygen and two hydrogens. Oxygen is way bigger than hydrogen. Oxygen is also way meaner than hydrogen. Oxygen keeps the electrons more than the hydrogen. So what ends up happening is that the oxygen side of the water molecule, which yes, it looks very much like a Mickey Mouse molecule here, has a slightly negative charge. Meanwhile, the hydrogen sides, or the ears of the Mickey Mouse, have a slightly positive charge. Right? So we draw that with this weird Greek symbol, which really means that it's not fully negative, it's just kind of negative. Right? So you might want to think like slightly negative, slightly positive. So, oh yes, biology, I definitely talked about this a lot. So that's important because that means water molecules are attracted to each other, right? Positive and negative is attracted to each other. So the negative side of the oxygen will be attracted to the positive hydrogens. So water likes itself, right? It wants to be near other water molecules. And water can form hydrogen bonds. Now, hydrogen bonds are the weakest bonds that there are. They're super easy to break. But because of the way that water is oriented with these negative and positives, it actually has pretty good surface tension. You guys have probably seen that, where stuff can walk on water, like tiny insects can. Things can float on water due to the surface tension, right? And you can break that surface tension. You might even have noticed if you've ever filled up a glass or a bowl with water, it kind of makes a dome shape on the top, right? That's the surface tension of water. It's not breaking yet. So water also is known as a universal solvent, which means that it dissolves a lot of things in it, right? It dissolves salts, sugar, right? Pollution, all types of other liquids and solids can dissolve in water. And a lot of it has to do with these positive and negative charges, right? Water can even conduct electricity because of these charges, right? More so if it has salt or something else in it. But it can by itself. Not super well, but it can. Right, which is a little scary. So water is pretty insane and amazing. Make sure you have a picture of it somewhere that you understand that there is an uneven sharing of electrons that gives water a charge, right? And that water can bond with itself using hydrogen bonds, which is pretty cool. So, changes of matter. This is really a review, I think. If you've taken science, you've probably learned this already, but they go over this in the lesson, so I wanted to make sure you guys knew about it for when you take the quiz. So, okay, I got somebody who needs the ID. Give me 1 second here. I want you guys to think about the answer to these questions. What does water need to change state? And is matter conserved in the water cycle? Sydney says, isn't that why people used to have that Ferris wheel looking thing with running water to produce electricity? Exactly, right? Because they figured out that water moving could produce electricity. So spend a second thinking about these two questions if you want to pop an answer into the chat, and then we're going to talk about it. See, what is my session ID? There it is. 779 306. Okay. Okay, so I see heat or cold. I'm guessing, Juliana, that is in the answer to what does water need to change state? Yeah, exactly. And if we want to sound technical here, right, can wind produce electricity? Yes. We want to say either a gain or loss in energy, right? Because if we add energy to water, then what's going to happen? It's going to go from solid to liquid, to a gas, right? If we keep adding that energy. And you guys could do that at your house, right? You could take some ice, you could put it in a pan, you could start heating it up, it's going to melt, and then eventually it's going to evaporate into a gas, right? The opposite is going to happen if we take away energy, which would be, in a sense, really we're talking about heat energy here, but you are exactly right. Oh, what happened here? That if we take away energy, we'll be going the opposite direction, right? We'll be going from a gas to a liquid to a solid. And somebody else asked, or no, somebody else said, Jack says, matter doesn't change, it stays the same. You're right. Matter is always conserved. All the time. Anytime you see anything about conservation of matter or energy, the answer is it's conserved. Matter's conserved, energy is conserved, always conserved, right? Because it's changing state, but it's not disappearing, right? If you have a certain amount of solid ice, when it becomes a liquid, it's going to be the same amount. When it becomes a gas, it's going to be the same amount, right? Water's not just disappearing. We may not see it because it could be in gas form, right? It could relocate to another part of Earth, but it's still there. Same with energy. The energy here, we're gaining or losing, but we're not destroying that energy or getting rid of it, right? That energy is just going somewhere else. Can water be taken out of a specific part of the cycle? Yes, right? So can we stop the cycle? Not really, but we can take water. We could take gas water, liquid water, or solid water at any point in the cycle and then add it back, which is what we're going to get into next, because humans, of course, we interfere with the cycle a lot. So just keep in mind, matter and energy, always conserved. Anytime you see a question about that, the answer is yes, they're conserved. Why? Because they can't be created or destroyed. Okay, so that was just a little review, right? Water is going to be gaining or losing energy, and matter is going to be conserved. So now we want to talk about how do humans impact the water cycle, and we're going to introduce one of my favorite concepts in science called eutrophication. This is not in the lesson, this is extra information for you, which refers to one of my favorite things ever also, surface runoff. Right, so this is one of the biggest ways that humans interfere with the water cycle. Eutrophication is where surface runoff that contains fertilizer causes imbalances in lakes or ponds. So we're gonna watch this video that's like super basic animation that goes through exactly what eutrophication is and how it happens. And I want you guys to be thinking about the impact on the ecosystem or the impact on the living and non-living things in this, which could include water, soil, fish, plants, etc. That's going to be one of the exit questions, by the way, so you're going to have to answer that later. I really like this animation because it reminds me of like really basic Microsoft Paint. So it could be by underground water, or it could be from surface runoff, right? It could be either. So we're thinking about how does eutrophication impact ecosystem? So fertilizer, what does it do? It makes plants grow, right? Guess what? That applies to water plants as well. Algae is not technically a plant, it's a protist, but it acts like a plant. So it goes out of control. You might have seen this even where a lake that's just completely covered in algae, right? And it's probably not a lake that you are wanting to go in, right? But some algae is good. If it's completely covered in algae, there's no sunlight getting in, that algae starts to die. So when there's a ton of dead algae in the lake, the bacteria in the lake start breaking down that algae and they steal all the oxygen because they need oxygen to do that. So everything dies, right? Fish die, the algae dies, the bacteria eventually die, and then essentially you have this disgusting dead lake, all because of fertilizer. R.I.P. fish. Yeah, exactly, right? So Moses Lake in Washington is known for having a ton of algae. Yeah, right? So part of the problem is once the algae starts growing like that, we can't really stop it. Really, you could take it out of the lake, but we can't stop it from growing without causing other problems. But essentially, if we do nothing, then everything dies, right? Including the fish that was just chilling there doing nothing. So that is one way that we can impact the water cycle, is that we put stuff in the water that then gets taken elsewhere, right? So even when we're, who is making so much noise on their thing? I feel like everyone's muted, but maybe not. Okay. If you're not muted, please mute yourself so we don't hear like crazy noises. So that's one way that we can impact the water cycle, right? There's a ton of other ways. Other things really that impact the water cycle are urbanization, right? i.e. cities. So concrete. Think about a parking lot. What happens when it rains really, really hard in a parking lot? It floods, right? There's nowhere for the water to go. So concrete's not porous. Usually, we'll talk about specific situations here. But water is forced to go to other areas, right, if it can. Otherwise, it just pools on that parking lot or concrete and floods. Even if it does go to other areas, it might flood that area because maybe there's not enough plant life there to absorb all of the water. Excellent, Sydney. It also weakens the concrete, right? Water sitting on top of concrete over time is going to cause potholes. Exciting, right? And it's going to destroy the concrete, and then we're going to have to rebuild it. So another thing is destruction of wetlands. Wetlands are like those marshy, swampy looking spots next to the ocean, right? If we get rid of those, then we kind of ruin some of the filtration of water. There's a lot of organisms that really depend on those wetlands to exist. Also, dams and hydroelectric power plants can ruin salmon runs, right? They can kill fish and marine life. Because guess what? Fish don't know what a dam is. They're not like, oh, let me just avoid that. They're like, let me try to swim through it, and then they die, right? Because they don't know. They've never seen that. They have no idea what it is. So those kinds of things can interfere with the organisms more so than the water. And then, yeah, they swim against the current, but eventually they're going to get to the dam, and then they're going to try to swim into the dam. Some dams have these like fish things where the fish can actually swim through this hole that kind of gets it through, but a lot of them die. And then pollution, right? If you guys have been to the beach and you've looked in the sand, what do you see? Tons of plastic and glass, right? Because guess what? Plastic and glass never decompose. They exist forever and ever and ever and ever, which is why we recycle them. But if you don't recycle them, they get broken up into little tiny bits, like in this picture here, and they kind of look like sand, even though they're not, right? And they end up inside organisms, and guess what? You have little bits of plastic inside of you. That will never go away. And ash, yeah, because of all the fires, there's also definitely going to be ash. That will eventually go away. But the plastic and glass never goes away, right? And some parts of the ocean and beaches, et cetera, have more plastic and waste than others, but it's there, right? So that's definitely impacting the water cycle, right, in terms of filtering through the ground. It can't be good for water to be filtering through plastic and glass. So the cool thing is Portland in particular, but also the surrounding areas of Portland, cares and thinks about these kinds of things, right, which most cities definitely don't. They just build concrete all over the place. And Houston, where I grew up, Hurricane Harvey, right, all that flooding, about 50% of that could have been avoided if Houston actually thought about preventing flooding, but they don't. So concrete everywhere. You barely see a tree. So in Portland, we actually have special concrete in some areas, which they have all these flyers. You can read about all the environmental stuff they're doing, but they have porous concrete where water can actually drain through the concrete, right? This is why on a lot of roads we can't put salt, because salt will destroy this concrete. But it helps because we get so much rain here, right? We need the water to go somewhere. So they actually thought about this. They thought, oh, we can build a special kind of concrete, which, yeah, they have a picture of it here. It has little tiny holes in it so that it can actually flow through the concrete and get into the water, into the ground and into the groundwater system, right? That's kind of cool. That's definitely not happening everywhere, but it's cool that it's happening here. Of course, that's not every road, right? That concrete is expensive. And of course, we would have to replace all the concrete that was already done. So hopefully, eventually, we could get to the point where all concrete is porous, right? We could also reduce our fertilizer use, right? Probably not a big deal to us because I doubt you're going outside into your yard and dumping a ton of fertilizer everywhere. But in case you are, stop doing that. That's more for like agricultural farming. Like if you have a huge garden or farm at your house, right, you want to think about how much fertilizer you're using and where that fertilizer is going when it gets washed away. Evelyn says, doesn't it take time to absorb into the ground? Yeah, but at least it can. It's more expensive because of the material. Yeah. Yeah, so it can absorb into the ground. Otherwise, regular concrete, think about like a piece of plastic. The water can sit on it and then go away, but it can't go through. And then there's also these little gardeny tree kind of things. I don't really know what they're technically called, but you guys have probably seen these on the streets, right? These little areas where they actually prevent people from parking right there by putting this. And they have a ton of trees and plants in there. Some of them have actually like drainage systems as well, right? Those actually do something, right? They help absorb a lot of the runoff from concrete because plants absorb water, right? So instead of this just being a huge sidewalk, now there's plants that can absorb some of that water. They can also help filter the water. Do they mix the concrete with something to make those holes? Yeah, I don't know exactly what the process is because I've never actually seen how they make it. I don't know if they say in here. Let's see. Specially formulated mixtures of cement with open graded coarse aggregate and water. Yeah, so a lot, succulents, yeah, that's what those are. So you guys are right. These, you might be thinking, whoops, that these are just decoration. You're like, oh, look, this building or, you know, this person or whatever has this beautiful yard or they have this beautiful thing, right? It's actually, it is aesthetically pleasing as well usually, but it's actually serving an environmental purpose here, which is to help absorb some of that water, right? And succulents are a type of plant, yeah, they absorb water. They're also really easy to grow, right? And they spread easily. So you could plant a few and they'll multiply. So if you see these things when you're walking around or going anywhere, right, those are actually serving a purpose to help the water cycle, really, which is cool because, like Yelena said, you might have just thought, oh, this is pretty, but it's actually having a purpose as well. So then there is a note here. Because in the lesson, there's this thing called the Cloud Lab that they want you to do. And guess what? You don't have to do it. It's optional. You don't have to turn it in. So if you would like to do it, you can, right? But it's not required. Let's see. Let me see what we got here. Having less water. Yep. Yeah, actually, you know what? If you do the Cloud Lab, I will give you some extra credit points. So you can just email me and say, hey, here's my Cloud Lab, and I'll discuss with you where you want your points added, probably to a test or quiz, right? So that increases your grade more. You could also wait on it until later in the semester and figure out what you want to add it to. But yeah, I'll give extra credit if you do the Cloud Lab. You don't have to do it. So that's pretty much it. We're going to do our DBA now, if you'd like. But before we do that, the exit slip is going to be these two questions. I made it so that it only shows up after 11 a.m. for you guys. So now you should see it. It's called Virtual Session 3, the water cycle. It should be on your calendar. It should also be in the very bottom of modules. It says these two questions, right? It says include the code word to get full credit. Guess what the code word is? I just typed it in the chat. That's the code word for today. Right, so if you include that code word, you will get 100%, assuming that you also answer the questions correctly. If you didn't attend live, the only thing that you could get is a 36 out of 40, which is a 90%, assuming that you answer the questions correctly. But the two questions are, what is eutrophication, and how does it negatively impact ecosystems? Right, which we saw that video, we talked about what it means. And is matter conserved in the water cycle? Explain. River, the code word, you're just going to put it in with your answer to the virtual session exit slip questions so that you could get 100%. Okay, so you guys should see this now. So as soon as the session's over, you could go in and answer those questions. And you're going to include that code word, which I'll type one more time in the chat. Oh, it doesn't have a submit button? That's a problem. Somebody's drawing on my screen. Please don't draw on the screen, or I will have to end the session and we won't be able to do the DBAs. Okay, it doesn't have a submit button. Let me fix that. For some reason, Canvas defaults to not having a submit button, which I don't understand because you would think you would always want to turn stuff in. But, oh wait, no it does. Should have a submit button. Anybody else not seeing a submit button? In fact, I'll just paste this Canvas link into the chat for you guys so you could go straight to that page. Huh, that's really strange, Amanda. All right, well, if it doesn't show up for you, Amanda, you can just send me an email with the answers, okay? And then I'll put your grade in for you, because that's should have submit. If anybody else has that issue, let me know. Okay, otherwise, we're gonna do the DBA. Okay, which is due today, right? And I thought, well, this will be a great way for us to get it out of the way for everybody, where we don't have to have individual conversations. So what we're gonna do is we're gonna go into a Google Doc here. If you already did the DBA with me, because you're ahead maybe, or you wanna do it individually with me, you're welcome to leave the meeting at this time, right? Otherwise, everyone else who would like to do the DBA right now, go ahead and follow us into this Google Doc, and you're gonna take a box and you're gonna put your name, and then the other boxes are gonna be where you're gonna write your answers to the questions. So go ahead and pick a box, put your name in there. We might need more boxes. Sorry, some of you guys might end up writing on top of each other as we fight for boxes. And if you guys like this, we can do this again. We can add some more rows here for the next DBA, just because I know that it can be hard to find the time to do the DBA with my schedule and your schedule and everyone's schedules. Okay. You can't do the DBA. Why not, Evelyn? You can't get to it. Click on the link. Oh, you're on your phone. Okay. So, Evelyn, you can type your answers in the chat and I'll put them into the box for you. Okay. So I'll be Evelyn in the Google Doc. Okay, we got one empty box. Oh, good. Everyone's ready. Woo. All right, you guys ready for the first question? Now, we're all typing at the same time, so try not to directly copy what someone else wrote, because it'll be kind of obvious. However, you're welcome to look at what other people are writing if you're like, I don't really know. But make sure you put it in your own words. So the first question is going to be, I have a box of random items. In this case, it's going to be a bunch of change. How can I find the mass of all of my random items together? That's the first question. I have a box of random items. How can I find the mass of all of my random items together? I like Ian's very to-the-point answer. You weigh it. So Ian, I'm gonna make it a little harder for you. What if some of my items don't stay on the scale? Okay, Jack, thank you. Okay, so I see lots of great answers here. You can find the mass by weighing them all together using a digital scale or a triple beam balance, right? Some people even went so far, River said here, to take the box with the items in it, right? So if you do have weird shaped objects, maybe they're rolling away, maybe they're, you know, not doing well on the scale because they're strangely shaped, you could put them in a container, right? And you could weigh that container. I saw Ian even said you could zero the scale with the container on it. Sure, right? You could definitely do that. Okay. Okay. Oh, there you are, Samantha. Let me add a row for you. Okay. So the second question, oops, is, I know it's laggy because we're all in there at the same time. It's okay. Do the best you can. In fact, you might want to wait, Sydney, until right now when I'm saying the question. Quickly type your answer. The second question is, what is energy in your own words? Remember, you're welcome to use your notes. You could Google the definition. I put your answer in there, Samantha. Just make sure it's in your own words. So how would you describe energy? Okay, Vitali, energy is strength or ability to do something like that. Energy is the ability to do work by heat, light, motion, etc. It's what is everywhere for mostly everything to do work. These are great answers, guys. Moves within a substance. It's good. It's what we use to do things. Mm-hmm. Ooh, a lot of examples here from Haley. It's potential or kinetic. It can't be created or destroyed. And it's used to make things come alive in their own way. Samantha says, I would describe energy as a power from a physical or chemical resource. Oh, I like that. If you haven't put an answer in for energy yet, keep thinking about it. So a few things about energy while people are finishing up their answers there, right? Energy has a lot of math associated with it, actually. But it's technically the ability to cause change or do work. And work is equal to a force times a distance. So when we're thinking about work, we're not thinking about like homework or schoolwork or going to your job work. We're thinking about a force moving something across a distance. And you guys are right with all of your examples here. That really that could be in a million different forms, right? There's so many types of energy, which a lot of people gave examples, right? But heat is a form of energy. Motion is energy. There's even potential energy, right? The ability to do something eventually. So work, the ability to do work is energy. And you guys did a great job explaining that. Okay. Are we ready for question 3? The last question. What is the one thing that you learned from the first module in Earth Science? The one takeaway that you took? So think back to the module. In fact, we can even look at the module topics in case you forgot what was even in the first module, because you might be like, eh. So we had like introduction to science, theories and laws, scientific investigation, measurement, atomic structure and forces, matter, and energy. So out of all of those things, all you have to do for this is pick the one thing that you think was the most important to you, or the one thing that you really learned from this module. Feel free to look back at your notes, definitely. I see a lot of people talking about the atomic structure interview with their element. Measuring was a huge takeaway from this unit, right? Making sure you correctly know how to measure volume, mass, etc., or module. What the hydrosphere was, yeah. Could be something as simple as that, right? Today, learning about hydro and osmo. Mm-hmm. Good. I learned that there are many types of energy. Everything in the universe has matter. Ooh, I see Haley talking about sodium. Yeah, sodium is insane, right? Because when it's not in salt, it's actually super flammable and dangerous. Atomic structure stuff. Nitrogen. Awesome job, guys. Cool, and that's something you should be doing as you go through all this stuff. Like, what is the important thing here? What did you learn from this? Right? Because now that was kind of like our introduction lesson or module. We're going to be going into a lot more earth science specific things, right? Going through a lot of different cycles in the earth. And then eventually we're going to get into talking about weather, earthquakes, etc., and all these changes in the earth. So as we go through each module, when you get to the end, that should be one thing that you always do is say, what did I actually learn from this module? How to differentiate a theory from a scientific law, that's a great one. Okay, I see a few people. Actually, it looks like almost everyone is done typing here. Awesome job, guys. So now I'm going to go into my grade book and I'll be putting in grades for your DBA for you, and you're done with your DBA. Keep in mind that once I put the grade in, it's not going to disappear, unfortunately, because Canvas is weird. So feel free to submit something saying, I did the DBA in the virtual session, right? Or we just did the DBA or whatever, anything, and I will just resubmit the grade and then it'll, go off your calendar. Okay, so I will also, if I see something that you wrote here that's, like scientifically incorrect, for example, I will leave you a comment. Okay, and I see people liked the way this DBA was done, so we will probably do the same thing for the next one. We might have to do it after it's due, but I will email you guys and let you know when we're going to do the DBA. Okay? Okay, awesome. So I see lots of positive feedback about the DBA, so yeah, definitely keep doing this. Otherwise, that is the end of this session. If you have any questions for me, feel free to pop them in the chat. I'll spend about 5 more minutes here if you have a specific question. Otherwise, you can now go into the last module in your course, and you can do your water cycle exit ticket with your code word. All right, so I'll wait here a little bit to see if anyone has questions. Otherwise, you guys are free to leave. Thanks for coming today. You have a question, Sydney? Oh, you can't get to the exit ticket? Do you want me to post the link again? Okay, no problem. Okay. Okay, that should take you to it. Can you get into it now? Yes. Actually, we could just do it through this if you want. I'll stop the recording though.